Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to another episode of the Reliability Matters podcast. Thanks for being in attendance today. I really appreciate you being here. And thanks also for the ever-growing subscription base. We're a little over, we just passed 15,000 downloads. So thank you so much for being part of this podcast family. I really appreciate your support. Today, we'll be discussing fit-for-use solder paste inspection. As I've repeatedly said many times in the show, in fact, I believe I even talked about it on the last episode, it's often said that reliability problems begin at the printer. Our industry utilizes a lot of materials in order to produce a circuit assembly. If the material, specifically the solder paste, is out of spec, that can affect reliability. Unfortunately, in most cases, one cannot simply open a jar of solder paste and give it the smell test or quick vision test and determine visually if the solder paste that they're applying to the stencil is actually fit for use, or if it has gone bad, or if it is out of spec. My guest today will discuss what solder paste fit for use is, and we'll talk about ways to determine if it's fit for use is there, and to determine that right there on the production floor. My guest also, on a completely unrelated topic, but maybe the most interesting question I've ever asked on this show, has experience in wearable electronics in temporary tattoos. You have not heard that subject on the show before. So that is definitely a first, and that's going to be the first question I ask. My guest today is Christopher Frederickson, Director of Engineering at InSituWare. Welcome, Christopher. Thanks for being my guest today.
Thank you so much for having me.
You're very welcome. Tell me, before we get into like the real stuff, like the important stuff, let's talk about the fun stuff. What in the world is a wearable tattoo? Tell me about it.
Oh, yeah, absolutely. Yeah. So, and interesting, that's more of just a like hobby project. So what I've gone through and done is integrated some electronics into a temporary tattoo. So that you can control things like a TV remote type of a thing in a wearable electronics device. So
I'm picturing change the channel. Yeah.
Oh, exactly. Yeah. You know, there's a lot of different interesting avenues and new applications that I always am interested in exploring. So. Integrating electronics into a temporary tattoo. It was based on a paper from MIT that I went through and replicated myself. So yeah, there's it's an interesting application.
Interesting is definitely an understatement. At some point in the future, maybe you'll come back on the show and give us a demonstration of a temporary tattoo. I'm sure you're not wearing one in your sleeve at this moment, right?
Nope.
That would have been too much to ask. Okay. All right. Let's talk about the real stuff now. Well, that was real stuff, but let's talk about the maybe less interesting but more important stuff on our agenda today. You stated in a previous interview that your company is all about measuring materials in electronic manufacturing for quality control. What materials specifically are you measuring, and what quality control purpose are you measuring these materials for?
Yeah, we focus on measuring a wide array of different materials. So in particular, we've focused on solder pastes, conformal coatings at the start. We're also looking at adhesives and die-attach adhesives, other materials along that line. And the focus that we take with a lot of these materials is to take different, is to allow you to go through and measure that material where you're going to use it. So materials are very dynamic. A solder paste, if you expose it to a different humidity or different environment, is a very dynamic material. So we're looking to expand the quality control processes that can be done for these materials.
Yeah, excellent. Let's talk about solder paste. That's the the most heavily promoted application of your product. Well, before we get into that, let's talk about in situ wear. Where did it come from? What was the genesis of in situ wear? You started in 2019, I believe. Is that when the company was launched?
Yeah, the company started, it was around 2018,
Okay.
where we were rolling into the development. Eventually, in the start of the pandemic, 2020.
Yeah, I'm going to ask you about
having
that. That's a great
product.
great timing. January, I think your debut was at Apex Expo. I don't know, February. Actually, I think it was right as the pandemic was starting. Right. Great timing, yep. Christopher. Great timing. Right. I'm sure. Well, but then again, if you can survive that, you can do anything. Right. It's. If you can survive a pandemic, a product launch during a pandemic, then you can certainly make it in any other environment. So what was the motivation to start this? Obviously, people have been able to inspect solder paste materials, quote unquote, forever. What was the genesis to create a different method of doing that?
Yeah, so the motivation behind adding these materials control solutions was the observation that there's different controls for all of your different processes in manufacturing. So after printing, you have SPI. At the end of the process, you have AOI. And when you looked at all of the different steps in manufacturing, there seemed like there was this big gap when it comes to the incoming materials. So in the case of solder paste, you really just rely on what's on the label on the jar. But a lot of different factors can then influence that material. So the genesis of the company was that observation that there really is a gap on the shop floor when it comes to monitoring and controlling the materials that are used in your process.
So it sounds like the justification, the motivation, the genesis of this was to take a service which has formerly been available as an outsourced laboratory test and bring that in-house for in-house inspection with answers, fairly immediately. Is that a correct assessment?
Yes. Yep. Absolutely.
Okay. When I think of sending stuff out to a laboratory, I think of a lot of expensive machines and engineers or technicians that are trained to interpret the data. No one machine says, yeah, this is good, this is bad. It basically produces a bunch of data, and someone has to know what they're looking at in order to interpret whether that material is good or bad or anywhere in between. This is a handheld device, which we'll show in a few minutes, that conducts an extraction of whatever elements, performs whatever tests it performs. I'll let you get into the details of that in a minute. My first thought would be something that is done outside of a laboratory may not be as sensitive, may not be as full function, may not have a wide spectrum of analysis as all the expensive hundreds of thousands of dollars worth of equipment and very well-trained scientists to interpret the data. Am I wrong there? Or tell me if there's any compromise on accuracy or the quality of inspection when it's done in a handheld device versus a formal laboratory.
Yeah, there certainly is trade-offs in developing and having a sensor in a handheld device versus what's available in a lab. And I think the biggest trade-off there is it limits the types of measurements, types of analyses that you can do. Whereas in a lab, you can go through and run through the entire suite of tests that are spec'd in the IPC standard for solder paste and flux. But when you're trying to adapt that to a manufacturing floor, it's prohibitive to go through that entire set of testing. So you have to limit the types of analyses that you're doing to ones that will work in that application shop floor well. So the technique that we end up using, electrochemical impedance spectroscopy, can shift and adapt quite well to that shop floor application without much trade-off in the actual accuracy compared to the same test in a lab.
Yeah, I'm showing on the screen right now. I'll let it loop one more time. Go ahead and look at the screen and tell me what we're seeing here. It's going to start over in just a second. There's a solder paste sample being put on some kind of test coupon, and that would be inserted into the handheld device. Is that correct?
Yep, so when you're using the product, you apply the solder paste onto our test coupon. We call it a probe. And then you plug it into the handheld unit, and you can start the measurement and get results on the EIS, or the behavior of that solder paste.
Is the handheld machine determining, running all the tests, or is it sending it to the equivalent of a cloud lab to run all the tests? Or how much number crunching is done in the hands of the operator versus just sending the data and letting the results come back?
It's a little bit of a mixture of both. So what we do is we do all of the data processing and analytics on the unit itself so that you can get the feedback and a result very quickly. But we do have a cloud backend that drives this product as well, because having just that one number isn't really that meaningful. So it really needs to be compared against a larger data set. So we use the cloud backend in order to do those sorts of comparisons.
I would imagine that's important. Again, I'm just hypothesizing here. I don't really know what I'm talking about, but every paste is a little bit different. The formulations are a little bit different. Some of the results might show that it's fit for use on brand A, but that same exact measurement might not be fit for use for brand B. So is one of the advantages of having a cloud-based support mechanism that new solder paste can be evaluated on your end and fed into the computer so that it's relevant on the shop floor? Is that one of the benefits of having a constantly updatable cloud-based laboratory, so to speak?
Yeah, absolutely. So what we go through and do is measure, we kind of call it the solder paste torture test, where we go through and work the paste to failure, expose it at high humidity, low humidity, run it on a stencil printer. We go through, look at it at incoming and the like, because every solder paste is a little bit different. Some are more sensitive to exposure to high humidity than others. Some, and they have very different behavior when it comes to EIS values as well. So we're looking at things like the activity level of that paste in this measurement, and that's different for each solder paste. So with it being cloud connected, we're able to go through, run that torture test, and then have the data available and have some of the insights gained from that available to anyone using the device.
So it sounds like somebody in your lab has a full-time job of breaking solder paste in order to find out where the breaking point is, right? And that has to be done on every brand and every species within a brand of solder paste. Is that correct?
That is correct. Yep.
Wow,
it is a full-time job.
Sounds like a fun job. What makes solder paste not fit for use? What are if I, in the cleaning world, I have a cleaning equipment business, and sometimes we'll give a demonstration on our stencil cleaner, our ultrasonic stencil cleaner, and we'll grab some old expired paste out of the fridge and go to put it on a stencil. We're not printing anything, so we don't care if it's fit for use. We want to make sure we can remove it. And sometimes we'll open a jar and it's just a brick. It's a total brick. It's so old, all of the volatiles, all of the flux components have made its way out. Every time we open it, we lose some, and it's just, that's pretty obvious that there's no fit for use except maybe a fishing weight. But outside of the obvious, what are some of the things that we are specifically concerned about with solder paste and its fit for use?
Yeah, there are really a few different phenomenon that we're concerned about when evaluating whether or not a solder paste is fit for use and looking at data using this measurement. So that same phenomenon that you're talking about does drive a lot of expiration of solder paste. So as that solder paste is sitting in the jar in storage, or once you pull it from storage, you might not think about it at all times, but the activator in that solder paste is constantly reacting with the oxide layer on the solder powder. And from that, you build up metal salts in there that increase the viscosity. You can use up some of that activator in the paste, and it eventually will become a hardened mass, and you can get cold welding, a bunch of other issues with that solder paste. And a lot of that failure is driven by that reaction that's going on between the powder and the flux, which drives its expiration and failure in storage. So what we end up doing with this electrochemical impedance spectroscopy is we're able to look at and extract information about that reaction that's occurring between the flux and powder in order to look at, is this solder paste too old, where it's might be less active, or the viscosity has changed slightly. So you can investigate defects like that, or even just variation lot to lot in the solder paste, or other factors.
In addition to, well, before I go there,
Yep.
what would you consider we're always there to catch mistakes. There'll be no shortage of business. We all have job security when it comes to solving problems, right? There'll always be problems in our industry, in any industry for that matter, but particularly ours because it moves at the speed of light, literally and figuratively. With that said, we can test to make sure we haven't made a mistake, by letting the solder paste go bad. But what are some of the methods to prevent solder paste from going bad based on the types of failures you see? And what's the best practice to make sure that every time they run a test, it just tells them that everything is good?
Yeah, the best preventative measures that you can take are the ones that I think are really already well publicized and known. So the manufacturer's guidelines are really quite accurate when it comes to handling solder paste, where you want to ensure that it's never heated up. You want to ensure it's kept at room temperature. Don't open the solder paste cold. You stir it to homogenize it well. If you follow to the T everything that the solder paste manufacturers recommend, in general, in a lot of cases, it will perform quite well. But there are plenty of areas where you can start to have run into issues where you start to deviate from that. So in shipping, that's a very much an uncontrolled process at times. You can't track and monitor what's happening to the paste during shipping, and so you have a little bit less control there. Same as during handling. So if you're following everything perfectly, these materials really are quite good. But there's always the traps along the way.
Yeah. Because your machine, your tool has to know what solder paste it's inspecting, so it knows what benchmark to compare it to. Can it also be used to ensure that the right jar was opened? In other words, if this is an obsolete example, but someone's running a lead-free or a lead flux for maybe some old military application, and they open the wrong jar, or they put a RMA flux in the tester, and they were thinking they were running a no clean or water soluble. Can the tool also let them know that this is out of spec? It may be perfectly good, but will it be able to tell them that the incorrect flux is being tested?
Yeah, every solder paste really kind of has a characteristic different phenomenon within it. So because of that, within the EIS data, you do see differences between different types of solder paste, and you can use it in order to detect, did I grab the wrong jar, or was there an issue there where it's really the wrong material? There are some limitations with that, in that some solder paste behave quite similarly,
right,
and you won't be able to catch it in those issues. But if the solder pastes are different enough, it can be used to catch if you are using the wrong material.
Right. It probably doesn't display a warning that you picked up the wrong jar, stupid. It probably just will say it's out of spec, right? Or it's failed. On that subject of what it says to the operator, you're collecting a lot of data. You're running probably several different types of tests and extrapolating and interpreting that data. How much, how little of all of that big data comes back to the operator? I mean, there's kind of damned if you do, damned if you don't. There are those who want to know the justification behind a fail, and there are those that just tell me if it's good or bad. I don't care what. So what types of information does it feed back to the operator relative to the reason it is not in spec or not fit for use?
Yeah, we really work to simplify what's on the unit itself for the operator in order to make it use it so that they can use it as really a quick indication. So we distill a lot of that analysis down to a couple different numbers that they can look at, which we call the powder reactivity coefficient. It's that interaction between the flux in powder and a flux coefficient, which is related to ion mobility in the flux, so conductivity in essence of that flux. So a lot of different failures of the solder paste will affect those numbers in different ways, but it allows the operator to just get that very quick indication. And a lot of the more advanced analysis we make available via a web application. So you can look at all of the raw data and get that additional insight.
And what's the science behind this? It's running some type of test. Does it run more than one test within a machine, or does it run one test and then interprets many results from that one test?
In a lot of these cases, it really depends on the specific measurement that we're doing. So we've built this out as a very modular device. So in the case of solder paste, we're running a test called electrochemical impedance spectroscopy, where we're able to apply a very small AC signal into the solder paste and read the impedance back and do some processing on that data in order to give information about the electrochemical and chemical reactions that are occurring within the solder paste. So in that case, it's you're doing one test and getting back a couple different data points about that material, depending on the specific solder paste. In other cases, we have other tests that are possible for other materials like conformal coating that allow the operator to get different insights about that material.
How do you handle custom solder paste? We talked about, you have the torture test. You have someone in your lab who goes around and gets samples of solder paste and then beats them to death, determines at what point it dies. Some solder paste is customized for very specific applications. Does that have to be sent to your lab first so that you could torture it and come up with a unique identifier for that? Or are there models that would work for a range of customized paste?
Yeah, what we have done when it comes to customized solder paste is we've had that sample of that material sent in, and we've run through that torture test on that paste as well. You can go through and run the measurement on a custom paste without going through and doing that torture test. You just lack some of the additional context surrounding that measurement. So you'll get back a number on what's in essence, how active is this solder paste, but you lack the context of, is this a good value or is it bad? So what we can offer as well, if there's certain cases where we can't get it in or we're not able to receive a sample, they can still go through and make the measurement on that material, but they just lack some of that context and would have to back it up using a different set of data, maybe SPI data in their facility or other process or other data that they might have.
One of the common, at least from my experience, one of the common failures of a paste is something completely solvable. It's just not mixed well enough before it's put into the stencil printer. And sometimes when you open a jar of paste, there's a little oily film on the top, as some of the ingredients separate. That doesn't mean it's bad. It just means it needs to be mixed up. Does your tool produce an answer that would indicate, for example, it's out of spec for this reason, which is common with not being mixed? Or is it just a green pass, a red fail? And, going back to my earlier question about how much of that data is given to the customer, knowing that these are probably not chemical engineers or physicists or whatever that are interpreting these results on the shop floor, nor should they be. How much of that information is useful to determine whether they throw it away or that they, try and restore its fit for use? Does that make sense?
Yeah. So I think in this case, there's a few different ways that you can use the electrochemical impedance spectroscopy for quality control. So in the case of you never want the measurement on the factory floor in order to be too complicated for the operator there. But these materials really are quite dynamic and complicated. And so when using this quality control tool for the application of making sure that the solder paste is stirred fully, what you can go through and do is set up control limits for your process for that solder paste, where you're always making the measurement post stirring, and you can look at how consistent was that process. So it's a single measurement, but it can be used in a couple different ways. You can measure the material just as it was received, but you'll get more variation due to the separation of the flux. You can measure it post stirring, and you'll be sensitive to both the material variation, but also the stirring process. So if it wasn't stirred fully, it'll be out of spec if you're setting it up that way. You can continue to stir it, see how that measurement changes to see if you're within your process window. Stirring absolutely is one of the areas where there still is a lot of manual processes there that don't have any sort of quality control step involved.
Yeah, it's frequently a very subjective process, right? Bob versus Amy. If Bob has a hot date on a Friday night, he's not going to stir it for as long as Amy might if she's sitting home watching TV, right? So, and I know there's equipment that can stir paste for you. I don't know, they're like high-tech paint shakers or something, but they can do it. But it's usually done by an operator, and then jar put back closed and put back in the fridge for another day. One of the things that I found interesting in one of your company's prior interviews was the statement was made that in your cloud laboratory that you use AI and machine learning. Tell me what that means relative in this context. That AI is a big word that's used by a lot of people. It's like in the 70s, everything was turbo. It was just a marketing term, right? And I think, not in your case, but whenever I hear artificial intelligence, I always kind of roll my eyes a little bit because everyone says they're doing AI, and very few people are doing AI. I believe in your industry you probably are, but tell me what machine intelligence and AI means in this context.
Yeah, in a lot of our case, what we've gone through and done is focused on building out a platform where we can go through and interpret and gain insights from a large volume of data. So AI really can mean quite a lot of different things to different people. So the way that we look at this and interpret it is more the machine learning point of view, and data analytics side, where you have the question of what insights can you gain from this large set of data. So some of the things that we've done, just as an example, is in looking through, now that we have a couple 100,000 measurements of these different materials in our database, and you want to gain insights and value from that data. And so you can do things because it's built up in a way that you can easily access that data and the like, in order to provide new insights that wouldn't otherwise be possible. So in the case of adding machine learning to this product, we are able to release new functionality that does things like, let's say you have a jar of solder paste and you want to gain some insights from that. You can go through and take a sample of it and get back things like a predicted flux designator for that material, things like what's the predicted stencil life of that material. So by building up this large set of data and building really a platform that allows us to easily interpret and analyze that data, we can provide new insights to the user of the device.
Yeah, that's fascinating. Do you recommend that a test be performed every time a jar of solder paste is opened? Does that make sense? How long does a test take?
The test takes about 3.5 minutes. So a quick measurement of the solder paste for each new jar gives you quite a lot of data that you can use to confirm that your processes are in control. So that is, take a sample of the solder paste each jar before you use it is a recommended process. But also you can do things like measure it at 8 hours on the printer to look at, can I get more stencil life out of this material, as an example, or measurements throughout the day to look at how it's changing.
I don't want to get into your pricing model, but I'm just curious, does every test consume a part, or is that, going back to that video, right here, that little part right there, is that used one time or is it cleaned off and used again?
For the solder paste measurement, that coupon is reusable. So you can clean it off and reuse it for, our recommendations about up to a week before it starts to degrade the gold coating on the surface. So that's reusable, but it depends on the specific measurement that we're making as well.
So there are cases where it can be reused for a week or so, and then there are other cases where you need a fresh test coupon or cartridge, whatever it's called, each time, depending upon what they're testing for, what they're testing. Is that the correct assessment?
Yep, exactly. So as an example for conformal coating measurements, it's a little bit difficult because the coating cures onto the probe.
Right, it conformally coats the probe, doesn't it? Yes.
It does conformally coat the probe.
Yes.
Yep, so that in that case, it doesn't end up being reusable. Solder paste, you can reuse it quite a lot without any problems. Only issue, some very active solder paste will start to eat away at the surface much more quickly than others.
Sure.
So it depends on the specific measurement.
Right. And depending on the cost of each probe, that would determine whether it makes sense internally to test every time a jar is opened, or maybe when a new jar is opened, or maybe once a week, whatever the case may be. That's an internal justification, I guess. A number of years ago, X-ray was brought into our industry, and our industry started using X-ray when BGAs came on the scene, because there was really no way to inspect the quality of a solder joint under a BGA outside of X-ray. In the early days, they had these microscopes with oblique viewers, very expensive viewers that would peek underneath the component and see as far into it as you can get. But clearly, you're only seeing the outer bands of the balls. And what was discovered through X-ray was they had a voiding problem. No one knew they had a voiding problem until X-ray showed up. It was a problem that was just unrecognized as a problem until X-ray showed up. Do you think that this technology, the fact that you're putting the ability to analyze solder paste for fit for use in the hands of many, many, many more people potentially that would normally not send out on a regular basis to a laboratory, they're probably discovering problems they've had all along, but just didn't realize it. So how big of a problem, based on your experience, is out of spec solder paste? Is it bigger than we think it is?
Well, I think the solder paste that is coming from the manufacturer in general is quite good. But where we see a lot of new insights and gaps is just how dynamic these materials are. So if you're running in your environment, if your humidity isn't really well controlled, you can get quite a lot of variation in that material, and it can be the root cause of quite a few defects in the printing process. So one interesting insight is there really is quite a lot of variation caused by humidity, handling, things like that, that is just right now not really well controlled. So I think as you if as you end up adding more quality control processes to the solder paste and to these other materials, you can really start to see more variation than maybe you might have thought initially.
A few months before the official product launch, I think this was probably September of 2019 in Chicago, your colleague and father, Michael Frederickson, talked about the plan to come up with an application that would test for cleanliness on a localized basis. I know that's not launched yet. Is that something that's in your crystal ball for the future?
Yep, absolutely. So the way we have built this product is to be very modular so that we can reuse the same sort of sensors for many different applications. So localized cleanliness has been one that has come up quite a few different times, and we're currently investigating that as a new additional module, along with quite a few other different measurements of adhesives, things like of that nature.
That would be very exciting. Me being in the cleaning business, it would be very exciting. There are methods for localized testing that are kind of a hybrid on the shop floor and then something sent to a lab. It would be very interesting to see if you guys could pull that off and actually have the results come back, not just a pass-fail or volume of contamination at a specific location, but identification of that contamination. That's something that I think Michael mentioned they had hoped to do. So I'll be your cheerleader along the sidelines and hope that happens. And then when and if that does happen, we'll certainly bring you back on the show, because that's a whole nother level of questions for you there. So you start, as we talked about earlier, you started this company literally the same month the pandemic was discovered and announced to the world. The pandemic has been very disruptive to many businesses in that probably for the electronics world, not so much in terms of the amount of business out there. That we're definitely an essential industry, and most EMS providers marched on. They had plenty of work. The struggles, the challenges were very logistical, and you couldn't go out and see people, you couldn't knock on doors, you couldn't sit in conference rooms, you couldn't attend symposiums or present at symposiums, because there really were none except a few virtual ones. And in the world of a product launch, you do all of that, right? So how challenging was the pandemic, and what did you do to kind of mitigate the challenges of not being able to put yourself and the product in the hands of users?
Yeah, the pandemic was very challenging, as especially at the start, where our product launch was pretty much timed with the start of the pandemic. And I think what's been most difficult is just how wide-reaching it is. So at the very start, it's supply chain disruptions, and then not being able to go visit different companies and the like. And now we have the global chip shortage. So the pandemic has really caused quite a few different logistical challenges throughout, and we've had to tackle them in a couple different ways. So not being able to go out and visit companies in person. We've gotten very good at giving virtual product demonstrations and going through and giving virtual evaluations where we ship out a unit to companies. I think there's still going to be quite a few challenges to overcome, and it's not really a replacement for a face-to-face conversation, face-to-face meeting. But like everyone else out there, you make the best with cards you're dealt.
Right, and it's a bit of a level playing field because there's no one else out there knocking on those doors either, right? And if they were, the doors aren't being opened. So, but we're starting to see a little light at the end of the tunnel, even with this, third wave or whatever it's being called. We are seeing a little light. At least there are some live conferences now coming up in November, SMT AI, and then Apex in the winter in January or so of next year. So high hopes for those. Maybe we can get back out and get face to face with customers. It's nice to see organic material in front of us rather than pixels, right? It's a nice change. Let's talk about conformal coating materials. That's also a subject in addition to cleaning. Conformal coating is, kind of close to me because a lot of reasons people clean is for good adhesion of conformal coat. You want that surface energy of the laminate to be very low so you have good adhesion. I understand that there's also a function, I think it's a newer application for your machine, that will allow you to measure the function, to measure basically conformal coatings before applications. Tell me more about that process. What is it looking for? What is it telling you is wrong with the conformal coating material?
Yeah, absolutely. So what we do for conformal coating measurements is we're using a technique called low frequency dielectric spectroscopy. So what this tells you is we're looking at the impedance of that conformal coating that varies depending on how it's thinned, for instance. So you can go through and use this measurement to understand if that coating has been thinned appropriately, if you're doing that in your process, to make sure that the solids content is correct. And it's also sensitive to things like the conformal coating being degraded and partially cured in the container, or contamination with moisture, for instance. So we're using this low frequency dielectric spectroscopy measurement to look at a couple of different phenomenon that occur within that coating.
And are you able to measure or evaluate any type of conformal coatings, from acrylics to silicones to parallenes to anywhere in between, or is it a specific species of conformal coating?
There are some limitations with the technique where the coating can't be, for parallenes, you can't really make a measurement of that base material initially. So you're not able to measure parallene coatings. Some silicones it's a little bit too resistive to make that measurement, and you're not really thinning them in a lot of applications. So it's urethanes and acrylics are most common and kind of best for this application. Epoxies as well can be used.
And is it mainly looking at the effectiveness of is it looking at, like, in another application, it would be specific gravity, when you thin something. I know this isn't necessarily specific gravity, but are you just making sure it's at the proper concentration, or are there other factors that would cause a material to go out of spec?
The concentration, well, with a lot of these conformal coatings, it is that that thinning step that I think has the most variation in that material. So in a lot of cases, that's still a manual process. So what we're able to do is monitor that process as well. But the other factors, like if it's exposed to the environment and you have absorption of moisture, which can impact the moisture cure of some of these conformal coatings, or if it's heated up too much in storage, you can start to see degradation of the coating itself. So it's a single measurement where we're looking at that impedance, but depending on it's sensitive to a couple different issues that can arise with that coating.
Going back to the subject of cleaning and cleanliness evaluation, one of the reasons to perform a cleanliness test is to try and get a crystal ball look at whether the conformal coat would adhere properly. There are specific types of testers that basically do a dyne test, basically automated dyne test, to see what the surface energy is on a particular surface. Do you see that as? I see that as a something that could easily go into a handheld device that would inject a solution, DI water or whatever, and then optically measure the refraction based on how much it's spread out. Do you see that as something in your wheelhouse in the future?
It's certainly something that we'll evaluate, and whether or not we'll add it to the Mark One, I think I'm not entirely sure about at this point. But that tester as well, going through and measuring the surface energy automatically, really is a wonderful tool to ensure that the coding will be adhered appropriately. Depending on it seems like it's something that would work well in a handheld tool, and we're always open to adding new modules.
Well, I'll send you a list of all the things I'd like to see.
Yeah, okay.
Right?
Yeah.
I won't be R&D, but I'll be market development. There's a lot of things I'd like to see in a handheld tool. So I think the last question is, and you brought this question on yourself. You called your product the Mark One, which just tells me that somewhere in the future there's going to be a Mark II, Mark III, Mark IV. Like an iPhone. I think today they just released the iPhone 13 or whatever they decided to call it. Will there be a Mark II? Will there be a Mark III? Is that the plan, or is it just the Mark One with 101 uses?
There will absolutely be new Mark One, new modules, adding the Mark II down the line, Mark III. We're building this out as a very modular, reusable platform. So the modules will always work with with new hardware and the like. So as we continue on, develop new hardware, we'll have a Mark II, but we'll also have new Insight modules and new modules that can plug in to do different sorts of measurements. So to really make it a very valuable and multi-purpose platform.
Excellent. Again, I usually ask one or two final questions. So one's a pre-final question. Maybe this is the final question. We'll see. Again, not wanting to get into details of your pricing. That's between you and your customer. But is some of this a subscription model, or do they buy a piece of equipment, a piece of hardware one time, and then run as many tests that they could do over the life of the equipment for the price they paid for the equipment? Or is it you do have a lot of stuff going on in the cloud. You do have a lot of investment that you continually make. You have to keep updating your databases of sample materials. It seems like if I bought a machine tomorrow and I'm still using it 10 years from now, I'm getting very exceptional value that I'm not paying for. But is there some type of model that the customer would have to, like a subscription or a fee per use or something like that, without getting into specifics of pricing?
Yeah, we've opted for a one-time, you purchase the unit. Wow. And continue to get value from it over the subscription model. We think that it's better for the end customer when they can just make a one-time purchase and continue to gain value. We have gone through and added other extended warranty services, other things where they can get added value from our lab with expert supports from our material scientists and things of that nature. But the Mark One itself, it's just a one-time purchase upfront.
Oh, that's great. I try really hard not to promote products on the show. I try and keep it as non-commercial and as technically relevant as possible. So thanks for following that. But I do find that a really good value, because if I buy a machine in 2021 and it's still working in 2026, chances are I'm using a different material in 2026 because of the evolution of these materials. So it's good to know that it's still relevant. To me, it's not how long a machine physically lasts, it's how long it's relevant for. And that model works very well in terms of value, because I know that I'm not just buying a picture of today's material sets. I'm buying a picture of today's material sets and tomorrow's material sets, which is represents a good value for an end user in any model, whether it's this or any other similar type of thing. when we build cleaning machines, we have two goals. Our goal is that the actual hardware of the machine will last 10 or 15 years, that, before it just wears out, right? And, but more important, that we can maintain as many years of relevancy as possible. There's no sense buying a $70,000 piece of hardware and then in 3 years you can't use it anymore. It's like selling 8-track tapes, today. It's like, great, but where are you going to play them, right? So I like that model. Well, that's it. You've answered my questions. I think it's a fascinating sector in our market to be able to deliver kind of a laboratory into the hands of everyday users. I think from many vantage points, it's a very fascinating business model that you put together, and I'll definitely look forward to seeing future modules come out, and with an emphasis on cleanliness testing and surface analysis and things like that. Are there any other applications today besides fit-for-use solder paste and conformal coating materials? Are there any other applications? See, I told you that was never the last question. Are there any applications that we've missed that today the machine is suitable for?
Today, nope, that's it. It's solder paste, conformal coating, constantly releasing new functionality, though, and working on the next thing. Excellent.
Well, Christopher, thank you so much for joining me today. How is it working with your father? How is it in the family business? It's always, I used to work with my dad many, many years ago, and I'm not going to put you too much on the spot, but what drug you into this family business? Just out of morbid curiosity.
It wasn't something that I was originally expecting, to be honest. So at the time, I was going through and doing a grad program focused on machine learning and data analytics. And so I've done a bunch of different built things like a scanning tunneling microscope and done data analysis, have focused on certain material, measuring different materials, things like that, just throughout schooling. And at the time when he was starting this, it just ended up being a perfect fit. So I came on board as the first engineer working on the initial conception of the product, and it has just evolved from there.
Excellent. You got sucked in. And now you're here forever. That's the way this industry works. Well, I'll look forward to, I think you're planning on being, I'm not sure if this show is going to air I don't think it's going to air before the SMT AI show. However, if you're watching this or hearing this, maybe you had a chance to stop by. I think you guys are going to be there, right?
You have
a booth there? Are you speaking there? Is your company speaking there?
So we'll be speaking at SMTAI and have a booth there. So we have a paper looking at correlations between SPI and the EIS measurement, as well as the booth there, and also a booth at Apex.
Excellent. Well, since this is probably going to air after the show has completed, for those of you who may have missed that presentation, many of the presentations are going to be available virtually on demand, I believe after November 15th. So if you missed the live performance, you can see the encore performance of InSituare's product information and or technical paper. Christopher, once again, I think I've asked my final question. So thanks for being my guest today. It's exceptionally informative, and I wish you and your company all the luck in the future.
Thank you so much for having me.
My pleasure. Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeConrad.com. That's Conrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.